Dory, hello. It is February 2024 and we are looking at the Cromemco OCTART multi-port serial card. Now this is a card from about 1980 something, I'd say 1982, something like that. They are quite rare and they are an independently driven, a CPU driven serial card with 8 ports. Now it's of course an S100 bus card, so we've got 100 connectors here, 50 on each side. This dip switch here is setting the address of the unit, and just I've printed out on this protective covering the actual port switches for typical OCTARTs. So that's to address the OCTART. You've got 2 headers here which you can connect to, and via a special splitter you can take each one of these and make them 4 serial ports. It's quite cunning that the first port is on the standard pins 2, 3 and 7, so you can take a standard cable which has got no fancy business at this end, and you can drive 1 port by connecting this cable in. So we can test a single port out of the 4 without any fancy splitter cable, which we will do. But this this card has a full CPU with 64K of memory, and believe me, in 1982-3 that was quite something. This card not only has the ability to support 8 serial ports, but it can also be used as a satellite processor. So back in the day, Cromemco systems had a DPU, then an XPU card with a Z80 68000 combo, 2 processors on 1 card. But later on they had a system CPU card with only the 68020 processor. So how would you run old Z80 programs, so programs written for CPM, programs written for CDOS? You would use a card like this and use its Z80 processor with 64K of memory to run those programs. So it's just a brilliant solution. So what we're first of all going to do is we're going to test this card today. We're going to put it into the Cromemco test system. So let's do that next. Okay, so we've placed the card into the test system. So we've got the chassis, which you can see here. The hard drive is in here. The floppy drives are here, and this has got this ingenious hinge mechanism which allows me to swing the whole of this out and get to the cards. Now Apple Computer, if you are watching, you've got this brilliant idea. You could construct a computer with a backplane and you could just plug in cards. You don't need to solder everything together. Anyway, let's zoom in. Can we zoom in any further? And you can hopefully see you've got the OCTART card sitting here. Now it has to be in a certain sequence, and if you see there's like a little wire, I can zoom in and point to it. So if you see this wire here, this is the interrupt wire. So this goes between certain cards which need interrupt capabilities under the Cromemco operating system, and you go basically from the out of one card to the in of the next card. So the cards plug into the S100 motherboard at the back, which is here, with up to 21 slots. And the OCTART card is sitting in the middle here because first in the priority chain is the diskette controller, then we've got the OCTART, and finally we've got the hard disk controller. And the highest priority is here, then here, then here. So it's going from the out of this to the in of this, then the out of this to the in of this. So we've got the cards set up from a hardware point of view. We're now going to jump back to a console screen. You can hear that the machine is on, making lots of noise, and we're going to continue the testing and initialization there. Okay, Darius, so we're at the base monitor prompt of the system. We're going to try and boot the operating system. We've actually got the operating system on a diskette. So we're going to boot the operating system from the diskette, and then it's going to jump onto the hard drive. Diskette number B, believe it or not. quite slow. You can't hear it, but it's loading it track by track. The operating system is about 120 kilobytes. So we're booting the operating system, so it's jumped to the hard drive. You see I put today's date on the operating system banner. And I've just put a comment to say that we're booting version 172 for the XU CPU. We're including hard drive support, ZIO, which means running Z80 programs on a satellite card, and support for multiple OCTART terminals, of which I've configured just the one. So let's look at configuration, but let's check first of all that the satellite Z80 card is working. Go into the bin directory and look at CDOS something. You see there's a program called cdoscopy.bin. That is not a 68,000 program. If I do version of ls.bin, you see that that's a 68,020 compiled program, source version 1.13. If I do a version of cdoscopy.bin, you'll see that there's nothing here, and that means to show that it's a Z80 program. So if I run the cdoscopy program minus list of FDC, floppy disk C, if this loads and runs, again, we must be using the Z80 processor. The CPU card that's booted doesn't have a Z80 processor, therefore it is definitely using the satellite Z80 processor. Let's give it a go. Yes! So, what we've proven? We've proven that the OCTART card, which is the inventory INV031, we've proven that OCTART card is working absolutely fine. And now we're going to see how is it working absolutely fine. Let's look at the startup file for the system. So you'll see that the startup file for the system calls a file called iostartup.cmd. So we're going to look at that file. So you'll see that this is a file that loads firmware into the satellite processor cards, and then there's some process that I don't understand, or it's never documented, as to how that satellite processor then runs the programs that you have loaded. There must be some, it must not just, IO load is not just loading the firmware into the satellite card, it's telling the firmware that's been downloaded to be run on that satellite card and establish communications between the main processor with its main memory and the satellite processor and the satellite memory. So you'll notice if we page down here that, let's go up a few lines. So we're doing this command, IO load this firmware into IO processor 2. So remember it's IO processor 2. We're going to come out of that, and then we're going to go into the operating system generation file, and we're going to have a look at We're going to have a look at the sysdef file that defined the operating system that we have just booted. So I'm going to do CE of 2024.0205.sysdef. So now we're going to delve into how is it that I built the operating system so that it actually works. So we've got things like the maximum amount of memory, well, that would be 4 megabytes, that's correct. And we've got the definition of the block devices, not the character devices. And we will see there's a block device called ZIO2. Again, let me just scroll the screen up a bit so you can see. So these are all the block devices. We've got the floppy driver, the uniform, that's all sectors of 512 bytes, special floppy driver. We've got the RAM disk, so you can convert a bit of RAM into a disk drive. We've got the hard drive, and we've got the remote satellite Z80 processor. So we're telling it, please have a satellite Z80 processor, and it's processor number 2. So now we're going to try and find the word ZIO. That's the word, find, must be with a delimiter, ZIO. Okay, A for again, A for again. Somewhere there's a definition of ZIO. So it says, ZIO supports Z80 processing, Z80 programs running in BIAT, OCTART and IOPX on one of the board. And we have chosen IO processor number 2. So you could have 2 cards, and then you could have IO processor, ZIO space 1 space 2, and then you'd have to put 2 cards in here, one at hex CE base address and one at hex BE address. So I've got one single OCTART card in this machine configured at hex BE, and I've printed out on the, it's too small to see I think, but you can see there's at least there's an indication of something. There's the label that I've printed out, and these are the switch settings for the cards. So it's all working, and I'm trying to show you why it's working. It's proof that the card is working because the CDOS copy program ran. The CDOS copy program is a Z80 program and cannot run under the 68000 processor. How did that Z80 processor run? It ran on a satellite processor card, which is the OCTART serial and parallel port card, which is versatile enough because it's got a Z80 processor with 64K of memory in there. In other words, it could be doing its work as a serial processor for up to 8 terminals, or instead of doing any work for serial processing, it can instead just be a processor. So when it's just a processor, you load a special firmware into that card, and instead of it's doing its serial processing tasks on an RS-232 interface with other terminals, it instead just runs programs. And it only works because I've configured the switches, which I poorly tried to show you a second ago, for the base address of this card to be BE, and I've put ZIO2 in the operating system configuration file. Then I've generated the operating system, and then what you would normally do is you'd put that operating system into the root directory. But because I'm testing this system, I wouldn't be that foolish, and I've actually put it onto a floppy drive. So there's a way of telling the computer when it boots to boot from either the hard drive or the floppy drive. And I told it to boot from the floppy drive. It read that program, that Cromemco.sys, that special Cromemco.sys that I generated. It read that and then booted onto the hard drive, and we see the results. So I hope that's a very long-winded explanation, but I think a complete one as to how to test an OCTART card, and it's definitely working. And you also know about the operating system's configuration. Thank you for watching, and as the last tidbit, I shall shut the computer down with the magical command. Good night.